So like Tracy said, it says DeployHub, but we're going to be looking at all the functionality of Ortelius. Basically, DeployHub is hosting Ortelius on a Kubernetes cluster in Google. So let's go ahead and log in here. And one of the things that we do is we look at the world through basically three types of objects. So we have our applications, and applications are composed of components, and then components have packages. So npm packages, Rust packages. That's kind of the lowest level that we dive into. Now at the component level, you can have different types of components. What we're going to be looking at today are going to be basically Docker images that have been built from source code. They created an image. This one I don't remember. When I dive into it, we can tell what it is. But at that point, we don't really care about the language. But the things that we do care about from our point of view is when was that image created? Who created it? How did we get to the build logs? Since this is an image that we're talking about, where was it eventually pushed through the digest and all those fun things? And then we get into the commit. So one of the things that we've noticed in the build processes that kind of get lost is the link between the source code commit and the artifact that was actually published. So that's one of the things that we collect out of the pipeline process.
In build is between
say about that I really like, because that's full pipeline. One of the things that I'm looking down the road on, first off, I like the embedding of the SBOM information that I need and some of the stuff that it does not get asked for that I also still need. So this is good. But why I like the commit is because increasingly, there's no way for me to actually mitigate and verify if someone has used like AI generated snippets. We're talking the logic is fine, but maybe there's a part of that logic which is an executional vulnerability. And now I'm by a large organization, I would have to be asked to scan line by line of your source code just to make sure we mitigate potential vulnerabilities. This can help me to see if there's patterns of vulnerabilities that are coming through from specific teams, and it saves energy on mean time to not repair, mean time to not having to repair. Love this. So thank
exactly.
you.
And one of the things, I'm actually going to stop my video because I'm getting a little bit of feedback here.
I did the same. It looks like we're
okay. So the now one of the things that we do is every time you do your build, we actually create a new component version. So we just have randomly, I wouldn't say randomly, but we've picked a kind of a format. So you have your component name. The next part is what we call the variant. So you can think of it as a feature. This usually typically is derived from the branch that you're on. Then the schematic versioning, then we just tack on the commit again, just for convenience sake. The last part's is not needed, but it is just helps pop things out without having to dive too deep into that world. So every time you do a build, you create a new component, a new artifact, you're going to end up creating a new component version. So we do have a CLI that we plug into your pipeline process that happens after the artifact is created. It may happen before it's like pushed to like Artifactory or Nexus or over to your Docker registry. It just depends on the nature of the beast. Docker images, you can't get the digest until it's actually pushed. So you have to actually wait for that push to complete before we can grab the appropriate digest. Now this is all versioned. Other things that we associate at that time are going to be like the service owner, any of the the Slack channel. Some of this detail over here can't be derived. So we have basically a TOML file that the developers supply us that say this is the who the owner is. That non-derivable data gets put there in the repository. So when you're looking at it from an SRE perspective, this service goes down. Who do I contact? How do I get a hold of them? Now, other things that we're able to grab out of the pipeline process is what's the README and the Swagger if they exist. Also, the license file, which is down here a little bit, that is used for this component. Any key value pairs that come into play that we want to persist with this version, because the reason why this is important is you can have the same component act differently based on the key value pairs. So we need to know what those are as well. Then, of course, the SBOM. We are not a SBOM tool, but we do consume them. So in this case, we ran SIFT as part of the pipeline. It generated the Cyclone JSON file, and we consumed that. Whether it's Cyclone or SPDX, it doesn't matter to us. We just are able to consume either format. And that gives us, yeah.
I always use Cyclone DX because I need better security information. It's literally, this is kind of like the form and function of behind lists. I would always use it. But I can produce both, but do you preference either? I personally
like Cyclone DX just for the exact same reason that you said. They seem to produce better better plurals, better ways to get to the security information is what we found versus the SPDX format.
Cool. I did have one note. So one of the things that I'm looking for or trying to create, so I'm trying, as we are dealing with supply chain security and understanding that every different organization has a different risk appetite, like a bank is different from a different organization. One of the things that I find useful is having the information, like the numerics around what your, not SLAs, but like SLOs are. And if you can, like last deployments, SLIs. And I like seeing that specifically for SRE. And for cybersecurity, I would like to be able to see that. I don't know if that's information that can be derived here, but for example, I'd like to know, like, did we intake known vulnerabilities in our last SBOM? And were there any consequences in that over the last 1, 2, 3 months? What was our risk appetite and what did we receive in return for that?
Yeah, and I'll show you exactly how we get to that. So this version of our component doesn't have any vulnerabilities. So we actually cross-reference our SBOM with OSV dev basically in real time. So if a new vulnerability is found in Hibernate tomorrow, it would show up. So the vulnerability list is more dynamic. The SBOM is versioned with this component, and I'll show you why we do that down the road. Some of the other things that we're able to gather are who's consuming us. So we have a concept, like I said at the beginning, components are packaged together into applications. So this component is being consumed by this application version. So not only do we do versioning at the component level, but we also do it at the application level. Other data that we are extending out and that we're going to be gathering are more of the things around like the OpenSSF scorecard, things like your fuzzing number, your branching profile for your Git repo. Those type of metrics we're going to be consuming as well, and adding them to our component version. Things like the Git commit signing, signed off by, those things are going to be added as well. As part of this, and it also depends upon the SBOM. If there's any signatures or attestations that we need to consume, we'll be adding that as well. It's one of these things, the chicken versus the egg. We're just setting it up so when that data starts becoming available to us, we can start capturing it and displaying it. We have a new version in the works, and that new version is we've extended upon the data model drastically to gather those that type of information. Now, one of the things, because we're versioning everything, we can actually compare and see what's happening at that between two different versions at the component level. So in this case, the older version I picked didn't have an SBOM associated with it, where the one on the left did, and we can see the different where things came from. One was off a master versus main, that type of information. I actually have another component. Let me close this one. And so I ran this earlier today. We're comparing two different version 1 of this microservice to version 201. And this is kind of talking to what you're discussing about the data. So in this case, we can actually see, based on the SBOM that was calculated or grabbed at when version 1 was created, we have our SBOM here, and on the right side we have our 201 version. We can actually see that when we did our update that our packages changed. So this is where developers clean up their code, their package dependencies. This allows us to really see how things are changing over time. And as a result, we can actually see that the old version had all these CVEs that were being exposed, and now the developers have actually resolved those with updating their package dependencies. They may not have necessarily changed any of their code, but basically did a dependency update, and they're able to bring in cleaner, fixed versions of the packages.
Okay. Cool.
So if we go over to an application version, I think it's this one. So like I said, application versions are going to roll up all the components. So we come from a DevOps perspective. So one of the things that we need to know is what does an application look like? So in our world, when you get into microservices, you have many little things running all over. We bring those together as a logical view. So our dependency list here is about a dozen microservices. At this logical application view, we are rolling up all of the SBOMs up to the logical application view. And again, we don't have any CVEs at this point for this version. And if we actually look down at our graph, we can see the dependency graph here. Now, if I go over to another version here, go to version 10, we can see that we do have some CVEs that did pop up. And this is coming from a couple things. There's a new version of the cart service, and I believe we could have brought in a couple other things, but that's the main one that's causing our headaches, is this new version of this service that the developers are using that actually introduced new vulnerabilities into our application.
Yeah, cool.
And if we actually do a comparison of those two, let me do these.
So I have two quick questions on this.
Yep.
So it looks like, if I'm understanding that graph at the bottom there, that's like just like source code dependencies. There was an interesting thing from Sonatype. It was a like temporary release thing, but was public, where they did a thing called Bomb Doctor, where it was a graphical analysis of the vulnerabilities and would show you where you should take the next action and at what layer. Like, would fixing a upstream dependency within your code base be the most efficient use of time? That was really helpful because that list, I mean, the problem, the anti-pattern that I can get into with this kind of visualization is the lack of understanding from the end developer of 0-day resolution and preventative resolution. So doing the highest risk, highest importance activity with their time to prevent security.
Right.
Yeah.
Yeah. So this view that we're looking at here is from the application to the individual component. We are going to be extending out the package dependencies into this graphical view. And then also we had a meeting earlier this week with the Guac team, and with their basically their package dependency tree that would be able to, that we're going to link into through their GraphQL to be able to do like what you're talking about. If I have this vulnerability and I fix this, I get this bigger bang for my buck type of resolution.
Cool. Yeah.
So if we go ahead and look at the, let's look at the comparison here. So we're comparing two different versions of the application. And one of the things that we recognize is not everything changes all the time. So actually in software, a lot of stuff becomes static, but we do have new things that pop up. So in this case, the one on the left, we actually added a Node.js, a hello world Node.js service that wasn't in the other version. And that hello world Node.js actually has a few dependencies. The other thing that changed was our shipping service. We basically changed the variant that we're using on that one. So we did have a change at two services that actually changed. The one that was most impactful was the Node.js one, and these are all the package dependencies just to run hello world.
Mm-hmm. Yes. On this note, are you offering or integrating with any like container slimming services? First step of security is slim it down.
Not yet. We have not gotten to that point. Where we're at right now is trying to gather the data and kind of consolidate it into a dashboard. And the next step would be able to do, like you said, the recommendations. This is what you need to do for, this is your next step for addressing this vulnerability. If you fix this upstream package dependency, then you're going to fix all these other vulnerabilities as well. The same thing goes with, like you said, being able to help developers and your security profile stance on what direction you need to take.
Yeah.
And a lot of this data, once we start collecting it and kind of making it available to folks, then we can get into the ML AI world where those types of technologies actually have data to work against. Right now it's kind of dispersed, and we're in the process of gathering things together.
Yeah. The one that you can lean on, that the Nexus repo in this last year has put out their, I want to call it Sonatype score, Nexus score, whatever you want to call it, but it puts together stuff like scanning for OSSF scorecard, all these best attributes, and it has like an 89% positive score on knowing that, or the likelihood of something not being vulnerable. So like you can choose selectively the right data to put into this dashboard that doesn't, like, you got to take your head out of remediation because we can get the data. It's really strong. If you can get the right data for those OS packages you consume, you can use that as a way to measure how much time you don't spend, which is interesting because acceleration there.
Yeah, exactly. We'll take a look at that. Definitely, because that the more data we are able to collect, the better we can inform people on what to do.
And the Nexus repo stats, they're there because they've got so much data and so many years back. But I would, there's one way to find out, but I would strongly suggest that like OSSF scorecard makes sense across different language spaces and different repos. They're probably good stats to lean on generally.
Yeah, and that's one of the things that we're going to be looking at is bringing in the scorecard, the OSSF scorecard for each. Basically, you know, we'll add a column for each one of the checks in the scorecard, whether you have fuzzing turned on, whether you have your branch protection turned on, you know, all those are going to be added. Our current scorecard right now is being driven by one of our customers. So they wanted to know things about their tool integration, about Sonar and Veracode. Whether they're, and this kind of comes into the Salsa model, is their bills being triggered automatically, or is somebody going out there running them manually? And then another interesting one that they wanted us to add was, because they hire consultants to do a lot of their work, how many of the consultants are actually contributing to the code base? So they want to know whether the consultants that they're paying are actually doing work. So we actually had, it was an interesting problem set, you know, you know,
Do they just measure that by individual commits? Can I like commit every time I change a line? And I don't know.
Yeah, basically there's ways to get around it. You know, we don't go and say that this person did 500 lines of change the lines of code, and this other person did you know, added a new line character. We can't distinguish at this point, but just to get a rough estimate, we're able to look at the total number of committers that are assigned.
You automatically are capturing the get commit at the end. So it allows, like, I can red team that super easily because I know the individual if they're a bad actor. So yeah.
Exactly. So what we do is we actually go through and look at basically do a git log and find all the committers that have committed either during a date range or on a specific branch, and then that gives us our number of committers. And then this is one of those numbers, the total committers has to be supplied to us that were assigned to that project or that team to work on. So that's where we can calculate the percentage of, you know, how many people that you're paying for are actually doing work. Other things that we're looking at the Swagger and README, whether those are available. And then we get into deployments. So on the back end side of things, we want to know where things were deployed to. So we have another hook into the deployment process that lets us know that this application version went to this QA Kubernetes cluster, for example. So that gives us the metrics on the backside to track where things went, and you know, how frequently things are happening to those environments that hold DORA metrics type of data collection as well on the back end.